Okay, we want to isolate x in order to put this in vertex form. So first we will add y squared to both sides. Okay, now at this point, if I divide everything by 4, I've just made things very complicated. So instead of dividing right now by 4, I'm going to complete the square on the right-hand side, and then I'm going to divide by 4. All right? It doesn't matter which order I do it in, just as long as when I do divide by 4, I divide every term. So because it's a lot easier at this point to complete the square for y squared plus 2y, I'm going to do it now. So I'm going to set this up to complete the square, remembering that we're going to add something to finish off the trinomial. And in order to keep the equation balanced, I'm going to subtract it off the same side because adding and then subtracting it is basically 0. Plus 2 minus 2 cancels itself out. Okay. What's the number that goes in the box? 1 squared. All right. Now, is there anything in front of this parenthesis that I need to take into consideration when I'm filling in the second box? It's an understood 1, so it really doesn't make a difference. So the same exact number goes in the second box. All right, now by factoring, and combining my constant terms, I am now here. But this is not finished yet because I have 4x equals all that stuff. Okay, so if I want x, now I'm going to take 4x and divide by 4. But remember, we must divide every term by 4. How many terms are we looking at in this last line? 3. This is a term. This is a term. And this is a term. Remember, big plus or minus signs that are not included in a group separate terms. So I've got to divide 3 terms by 4. So if I divide this by 4, I get x. Dividing this by 4 is the same thing as multiplying it by what? 1/4. And we're going to write it this way instead because I can't really divide it by 4 anyway. And then dividing this last term by 4 gives me 3. Okay?
We could just keep it.
No, because you want to be able to identify that the A term is 1/4. Because remember, in your final thing, you've got something times y plus 1 squared. You don't have that whole thing in the form of a fraction. Okay, now, last week we looked at these types of equations and said this is a sideways parabola, right?
Yes.
Okay? This specific parabola, the A term is 1/4, which means that it's opening to the, and the vertex is located
3 negative.
at positive 3, negative 1. Remember, the y coordinate of the vertex is in here with the y variable. All right? Now, today we're going to learn 2 more pieces of this puzzle to be able to graph these things better. In assignment number 3, you did that assignment and you took all those equations and you put them in vertex form. Tonight, you're just going to take out your assignment number 3 and add on to it. Okay? So you've already got those equations in vertex form. Then you're going to identify the 2 things I'm going to teach you today, and you're going to graph those equations. All right? Okay, well, the 2 things that I'm going to work with you on today are... I didn't name it this. So I'm going to say the name once, and then we're going to call it by its abbreviation. The first thing is called the focus. The second is called the latus rectum. We will say LR. Okay? Now I want to draw a picture and let you see exactly what the focus is and what the LR is and how we use it to graph a parabola. If I have an XY axis, and let's say that I have a parabola opening up, and this is my vertex. I want us to think this stuff through. I don't want it to just be formulas that we memorize. I want us to think it through. If the parabola is opening up or down, and the vertex lies there, where does the axis of symmetry lie? Straight through that vertex, right? Because the axis of symmetry is an imaginary line that splits the parabola in half. Okay. The LR is a line segment that is centered around the axis of symmetry. And the endpoints of the line segment tell you 2 points on your parabola, okay? Now the focus is the point, or excuse me, is the midpoint of this thing right here. So if the focus is the midpoint of this, what do you think the focus lies on? The focus sits on the axis of symmetry. Because if it's the midpoint and the LR is perfectly, and this may not be perfect, it looks good from right here, but from straight on it might not be. The focus tells you basically where the LR sits. If the focus is located here, then the graph of this parabola would look something like this. But if your focus is located way up here and your LR is still that length, what has happened to your parabola? It's a lot skinnier, okay? So this is how the focus and the LR are related to each other. Now let's talk about how we find them. Let's go back here.
Something to do with it.
Something to do with what? No, it doesn't have anything to do with slope. All right. One more time. The focus. What is this? Is it a point on a graph? So is it going to have an X and a Y coordinate? Yes. Okay, now let's think about this. If your parabola is opening up and down, and the axis of symmetry is the center of your parabola, are all X values the same on this imaginary dotted line? Yes. So on your focus, if it's sitting on this imaginary dotted line, is its X coordinate going to be the same? Yes. All right? Now let's flip this around. Suppose we have a parabola that does this. Now my axis of symmetry goes this way. Are all of the X coordinates the same now, or all the Y coordinates? All the Y coordinates are the same. So the focus on this one will have the same X or the same Y coordinate as the vertex? The same Y coordinate as the vertex. All right? Now the way we find our focus is a simple adjustment to one of our coordinates of the vertex. Okay? We've got to decide which one to adjust. But by being able to see and visualize that if my parabola is opening up, I can't change the X coordinate. If my parabola is opening to the side, I can't change the what? The Y coordinate. Okay? All right, so let's go back and let's talk about our focus. How do we find it? The focus is a simple adjustment to one of your coordinates, and this is your adjustment. You are going to add 1 over 4a, okay, to one of the coordinates. That's your adjustment. Now, no, it has to be specific. This is a side-to-side parabola, right? Imagine a parabola situated perfectly on each side of